So this is a cosine function. The equation is y equals cosine x, and the symmetry is even. Boundedness is bounded, and there are no asymptotes. And this is the graph. The discontinuities is continuous. Extrema is absolute max of 1, and then absolute min of -1.
Alright, so this is the exponential function, and the equation for this is y equals 2 to the x power. So for this, we have two examples. The first example we have for y equals 2 to the power of x. This is the graph of it. The symmetry is neither. It is bounded below. Asymptotes for the horizontal asymptote, it is y equals 0, and there is no vertical asymptote. It is continuous, so there's no discontinuities. It's increasing from -infinity to infinity. It's never decreasing. There are no extrema. The domain is from -infinity to infinity, and the range is from 0 to infinity. And the end behavior for this is limit f of x equals infinity for x of infinity. And the limit f of x for x of -infinity is 0. Other example, which is y equals 1/2 to the power of x, we have symmetry as neither. It's bounded below. The asymptotes for horizontal asymptotes, it is y equals 0. Vertical asymptote, there is none. Discontinuity, there is none. It's continuous. It's never increasing, and it's decreasing from -infinity to infinity. The domain is from -infinity to infinity. Range is from 0 to infinity. Extrema, there is none. And behavior, limit f of x for x is infinity equals 0. Limit f of x for x is -infinity is infinity. And this is the graph for y equals 1/2 to the power of x.
This is the sine function. The function is sine, or f of x is equals sine x. The symmetry is odd because f of -x is equal to -f of x. There are no asymptotes. The extremas are an absolute max of 1 and an absolute minimum of -1. It is bounded above and below. There are no discontinuities because the equation is continuous. The domain is -infinity to positive infinity. The range is -1 to 1, and the end behavior is the any.
What does that mean?
Does not exist.
Does not exist.
This is the parent function for a logarithm. The domain is 0 to infinity, not including 0, and the range is from -infinity to positive infinity. And there's no symmetry, and it's not bounded because it keeps increasing. There's an asymptote at x equals 0. There's no discontinuities, and it continuously increases from 0 to infinity, like the domain says. And it doesn't decrease, and there's no extrema. And the end behavior is as x increases, y, or as x gets larger, y gets larger, and as x gets closer to -infinity, the limit does not exist because the y continuously gets closer to the asymptote, which is x equals 0.
The absolute value function is f of x is equal to the absolute value of x. There's symmetry across the y-axis, which is even. It's bounded from below. There's no asymptotes and no discontinuities, and it's increasing, including 0 to infinity, and decreasing from -infinity to including 0. The extrema is the absolute minimum of 0 at x equals 0. The domain is -infinity to infinity, which is all real numbers. The range is 0 to infinity, including 0. And the end behavior, the limit of f of x when x is approaching infinity, so y keeps getting larger. And the limit of f of x when x is approaching negative infinity, the y also gets larger.
Okay, so for the square root function, the symmetry is none, the boundedness is below, and the asymptotes are none, and the discontinuities are continuous, so it doesn't have one. And it increases at 0 to infinity, or 0 comma infinity, and the extremum is absolute min of 0 at x equals 0. The domain is 0 comma infinity, and the range is 0 comma infinity. And the end behavior is the limit of f of x is infinity when x is going to infinity, and the limit of f of x does not exist when x is going to negative infinity.
Okay, this is the logistic function. It is f of x equals 1 over 1 plus e to the negative x. It has no symmetry, there are no discontinuities, there are no extrema. The boundedness, it is bounded above and below. It has a horizontal asymptote, two of them, y equals 0 and y equals 1. It is increasing from negative infinity to infinity. For the end behavior, the limit of f of x when x is approaching infinity is 1, and when x approaches negative infinity, it is 0. The domain is infinity to 1, and the range is 0 to 1.
It should be infinity, negative infinity to infinity.
To infinity.
Yeah,
Okay.
because it's all your x values. You want to fix that on your poster?
Yeah.
This is the natural function. It has odd symmetry.
The
It is
natural function. Inverse.
inverse function.
Rational.
It is not bounded. There's a horizontal asymptote at y equals 0 and a vertical asymptote at x equals 0. There is an infinite discontinuity at x equals 0. It is decreasing from negative infinity to 0 and 0 to infinity. There are no extrema. The domain is negative infinity to 0 and 0 to infinity. The range is negative infinity to 0 and 0 to infinity. The end behavior as x approaches infinity is 0, and the end behavior as x approaches negative infinity is 0.
The greatest integer function. The equation is f of x is equal to integer of x. And we can also put f of x brackets with x on the inside. There's no symmetry. It's not bounded. There's no asymptotes. It's a jump discontinuity at all integers. There's no extremia. It's increasing from negative infinity to infinity. The domain is negative infinity to infinity. The range is all like the y is like all union integers, and the end behavior it just goes just like to infinity. To infinity, it just goes to infinity, and to negative infinity is like no limits.
This is a linear function. The equation is f of x is equal to x. It has an odd symmetry because there's a reflection over the origin. It is not bounded. It has no asymptotes, discontinuity, or extrema. It is increasing from negative infinity to infinity. Its domain is negative infinity to infinity. Its range is negative infinity to infinity. Its end behavior, its limit, the limit of f of x as x approaches infinity is infinity, and the limit of f of x as it approaches negative infinity is negative.
This is the cubic function, and it's symmetric with respect to the origin. It's odd. It's not bounded, and it has no asymptotes, and it's continuous. It's increasing from negative infinity to infinity. There's no min or max. The end behavior as it approaches infinity is infinity, and the limit of f of x as it approaches negative infinity is negative infinity, and the domain is negative infinity to infinity, and the range is negative infinity to infinity.
This is a quadratic function. The formula for a quadratic function is y equals x squared. This is the graph of the function's parabola. The symmetry is even. The boundedness is below, is bounded here. There's no asymptotes, no discontinuities, and it increases from 0 to infinity and decreases from negative infinity to 0. The extrema, it's an absolute minimum of 0 at x equals 0. The domain is negative infinity, infinity. The range is 0, infinity. And then the end behavior, as it approaches infinity, it goes, or as x approaches infinity, it goes to infinity. And as x approaches negative infinity, it goes to infinity as well.